All right, so our next section in our AP review, so we're going to go over our units 2 and 3. They actually did take a lot of time during the year introducing these concepts, but I'm hoping that a lot of them have carried through and that you've kept them. So this review actually is going to be quite short, even though this will take 15 to 23% of the exam. Okay, so we want to remember graphical displays. Categorical is those bar graphs. So you have different ones for categorical versus quantitative. Remember that bar graphs have that separate space in between the bars, but histograms are for quantitative. So those are the ones where the bars touch. Okay, and then again for categorical, you could have the segmented or stacked bar graphs. Remember, one of the things that we look for with those segmented or stacked bar graphs is if the categories are the same size for the two different variables, okay, or the three different variables or whatever, then that's saying that the variables are not affecting each other and you have independence, or there is no association between those things. So that is one thing that will show up, especially in, say, a free response problem, looking for if the stacks or the bars are same size, or if they are different sizes. Different sized bars would mean that the variable is having an impact. Okay, so the fact that you are a male or female is affecting the rate at which you eat breakfast or whatever it is about. Okay, we know pie charts, and then remember those mosaic plots. Those are the interesting ones where the size of in both directions, in both the x and the y direction, is giving you an indication of the proportion of the data in the whole sample, not just the proportion in one category. Okay, so hopefully you'll see come across one of those in your work. All right, and our box plots. Okay, remember making our box plots: scale, box, fences, whiskers, scale, box, fences, whiskers. Okay, and so on. Now, if you are making a graphical display on a free response, which is very possible, okay, that is not unheard of. That happens probably once every few years. Make sure that you are labeling everything. Nothing will mark you off faster from an essentially correct to a partially correct than leaving off those labels. Okay, so everything must be labeled. All right. Now, remember that we, based on the data, we have a choice for quantitative of which measure of center or spread is better to choose to use. Remember that if you have skew, or if you have outliers, if you have skew, then you must choose to use median and IQR, because median and IQR are resistant because they are just that middle section which cuts off the outliers, okay, or would kind of take away that impact of the skew. So median and IQR are resistant to that skew and outliers. Symmetry, however, symmetry, standard deviation, and mean. And again, you need to know that mean and standard deviation are not resistant by skew and outliers. They are impacted. Okay, so that's some language that you could see very easily is about the resistance or not being resistant to skew or outliers. All right, now remember that thing about writing mean, median, and mode. Mean, median, and mode. And then, based on that shape there, let me get my pen to write with. So then, based on that relationship there, if you've got skewed right, then you have this. The mean is greater than the median, which is greater than the mode. And then, of course, for skewed left, okay, skewed left, like looking down at your left foot, remember the shape? The skewed right is like looking down at your right foot. But for skewed left, your mean is less than the median, which is less than the mode. Okay, symmetry, they're about the same. All right, I think we know our box plot rules are Q1 or Q3 plus or minus the 1.5 IQRs. And of course, we're very familiar with the mean plus or minus 2 standard deviations. All right, next, transformations. Okay, remembering that if I say, this happens commonly if I'm changing units. Say I have number of credit hours and I am changing it to the cost for the semester. Okay, so then we have, say, like a down payment for student fees plus so much per college credit hour. So the mean cost for students is affected by add, subtract, multiply, divide. So that's, remember, the ball that I have, the adding and subtracting, multiplying and dividing affects spread or mean, center, and median. Okay, but then remember spread. This spread of it is not affected by the adding and subtracting. The variability is only affected by that multiplication and division. Key there. All right. If you are asked to describe the distribution, this is very possibly going to happen. This is a common free response question. Okay, so to be thorough on this free response question, you need to make sure that you talk about the shape, the outlier, the center, and spread. Describe with your socks. Shape and outlier, center, and spread. Okay, so we want to describe those. When you describe the shape, you're telling me unimodal, bimodal, multimodal. Actually, do not describe the shape as normal. You have to say symmetric and unimodal because there's criteria. We know now there are conditions and criteria to be able to say approximately normal or whatever. So normal is not the correct description of a shape unless we have actually met the criteria and checked for the random independent large enough. Okay. Of course, outliers, you can check for those, and center, you want to state specifically, okay? Be specific on free responses when you are doing this. Say, the mean is this, or the median is this. State the specific numbers for center and spread. All right, and of course, also for outliers, you can say there's two or three outliers past this point. So you can state where that fence is and where those outliers are. All right, now, if you are asked to compare the distributions, then be very mindful to not say, oh, here's the socks for this distribution, here's the socks for this distribution, and then be done. No. Connect and compare. Use comparative language. This one's center is higher than this one's center. Higher than, comparative language, higher than, lower than, because the mean of this one is blank and the mean of this one is blank. I comparative languaged it and I used specific numbers. Okay, comparing the distribution. Make sure you compare. Don't just list these separate things. Now, for this normal model stuff, I think I'm not going to go into that because we are so well versed in all the normal model things. Of course, when it's standardized, a z-score of 0 is where the mean is, and the standard normal model has a standard deviation of 1, and that area under the curve is 1. Okay, so I think that we're good with then all of those. Now, just again, that one word of caution, which I think that we hopefully get this. If they say percentile, then that's the area below. So if they say, what is the grade for the 80th percentile, then you would want to find that z-score at the 80th percentile. So you inverse norm the area below is the z at that spot, okay? So percentiles at area below, and then you know what? For heaven's sake, if they say, what is the grade at the 80th percentile, 0.8 is not the z-score. Percent is not the z. It's not the z. If they give you a percent, you're going to use that percent, but you're going to use it to get the z-score. Use area below as the percent, okay? If they say the top 80% or the top 10%, okay, what grade is the cutoff for the top 10%? Then when you inverse norm, you've got to do those lower 90% to find that z-score. Okay, and then I think this page just has a little bit reminding you of the standardized percentages of your 68, 95, and 99.7. All right, so now you're going to start on the review for this, and I think that the pages, it's a lengthy review, okay? So I have you doing just pages 16 to 26, and then those are due before class, of course, on Monday, which is then when we're going to go over pages 20, we're going to do pages 27 to 33. So at the end of this review and going over it is a quiz over units 1 through 3. So you'll want to be prepared for that. Okie dokie. So good luck to you on your descriptive data practice.